times have increased. There is inadequate public transportation system that is there. There is a huge difficulty for non-motorized travelers. The environmental impact and the energy consumption. So that has also played a very significant role because of these transportation issues. And also, it has also led to an alarming increase in the number of accidents and safety related issues. So, if you look at the leading causes of deaths 2 decades ago, it was heart disease and cerebrovascular disease, which were the top ones. And road traffic injuries used to fall at around number 9. And in the past 2 decades, it has already bumped up. And by 2030, it is expected to reach at number 5, bypassing the uh, major diseases like HIV, AIDS, stomach cancer, and diabetes. Road traffic injuries is going to be the fifth leading cause of accidents and deaths. If you look at the fatalities of different types of road users, so in different parts of the world, the numbers are different, the proportions are different. But if we look at Southeast Asian countries, where India also lies, we see that 43% of the fatalities, they are motorized two-wheelers and three-wheelers. Okay, they are the vulnerable road users. Whereas in other countries where the proportions of car is much higher, in Southeast Asian countries the proportion of car is just 16%. Okay, so to understand road safety and its move towards sustainability, we have to first understand what we can do to improve safety, and then how we can bring in sustainability in the safety of road users. So to understand that, there are different components of urban intelligent transportation systems. So these include ATC, that is called area traffic control. Then there is traffic and travel information. There is integrated fare collection. We have multiple public transport applications. There is RLVD, that is red light violation detection, and there are smart parking solutions. These are just few of the components of ITS. There is much more in urban ITS which can help us in improving road safety as well as improving sustainability issues that are arising due to the increase in the traffic and the congestion that is happening due to the increase in number of vehicles and number of trips that we're making. So one of these components is advanced travel information system, that's called an ATIS. So an ATIS basically can be utilized for two different purposes. One is a public transport system can use an ATIS where you can have different type of real-time information about the different type of public transport routes, the upcoming arrivals, how realistically and how reliably the public transport system is following the pre-decided schedule of their routes. This leads to a lot of a sense of reliability on the public transportation network. And if you may have seen, if you have traveled by a metro rail system and if you have traveled by a bus system, the primary difference is that the metro systems have an inbuilt ATIS where uh, even if you are not at the metro station, on your phone you can check when is the next metro going to arrive. And even when you reach the metro station, at various variable message signboards you will find that the next arrival is in 5 minutes, 3 minutes, 2 minutes. It's written everywhere, and the metro actually arrives at that time. Whereas in the case of buses, it is not that accurate because ATIS has not been properly integrated into bus network systems. Then ATIS is also used for your regular private vehicles as well. So in private vehicles, uh, everybody uses Google Maps. So Google Maps is also a kind of an ATIS system only, where reroute Google Maps also does rerouting for us. If there is some incident or event that happens on a road somewhere, then Google Maps will reroute traffic to reduce your travel time and take the traffic away from the congested area. That is exactly what an ATIS also does. Then people can also fetch pre-trip traffic information. Like if I'm planning my trip that I wish to leave to from point A to point B tomorrow at 10 p.m. So what will be the traffic scenario expectation at that time, and accordingly, trip can be planned for reducing my travel time and uh, reducing the kind of congestion that one would face, and that definitely will be leading to much more emissions and much more uh, sustainability related issues if we're moving in the congested time frame. The ATIS also comes with a traffic control center and a traffic information center. So most of the, not most, all of the smart cities that are there in India, they now have an ATIS system which has a traffic control center and traffic information centers. So there you can see the live traffic scenario of most of the intersections of the city, and basically in a control center you know everything how the traffic is moving in a city. Okay, and there can be many applications of such kind of a control center in the ATIS. You can even monitor the existing conditions of traffic, and it can be extremely helpful to manage any incident or quick response to any disaster management within the city. Even if you have to move an ambulance from point A to point B, with the help of an ATIS system, you can simply clear a corridor very quickly for extremely fast movement of an ambulance or a fire truck or any other uh, extreme situation movement that is required for disaster mitigation. The earlier versions of ATIS used to be some signboards like this. Nowadays, we have digital LED screens where we can display pretty much any kind of information that we want for the road user. Then, earlier versions of ATIS also used to have radio channels where people could communicate with one another with the help of radio frequencies. And there are various kinds of ITS applications in transportation where we use different kind of sensors for acquiring data. We use inductive loops, we use passenger counters, piezo sensors, we use lasers, radar, CCTV. There are so many things that are available today. For communication, the way we communicate, the way vehicles communicate with each other, it has changed drastically. Data analysis, data mining, it has also improved many folds. If we look at the traveler information system, so as I just showed you the previous versions of VMS, they were quite rudimentary. Fixed messages used to be there and radio waves used to be there. Now we have true VMS where we can display pretty much everything. We even have in-vehicle information system where we can relay some of the important information for the drivers to actually give them useful information at the right time, and that can be very helpful for a driver to make the correct decisions at the time while they're driving. For the sensors that I just mentioned, so there are different kinds of sensors that work at different kind of electromagnetic waves. Just we'll not get into too much detail of what are the wavelengths and what they do. Just to briefly understand, the visible spectrum is a very small spectrum in the entire frequency of waves that are available with us. Everybody must have heard of infrared, microwave, radio waves, ultraviolet rays, X rays, gamma rays. So these rays are not visible to us, but that does not mean that they are not useful. With the help of these waves, we can detect different type of objects, and with the help of object detection, we can make use of that information and strengthen our intelligent transportation system architecture. Okay, sorry. So with such technologies, there are numerous areas and applications of safety and Some of them include blind spot detection. We will be touching upon a few of them today. So we will look at blind spot detection. We will look at intelligent pedestrian traffic signals. Then we will also look at intelligent speed adaptation. Red light cameras are there. Then intersection safety is there. Pedestrian detection systems are there. Then information on vacancy of parking, whether it's for bicycle or for car, that's called smart parking. Those are there. Then adaptive lighting is there. We have ride monitor system. We have driver behavior monitoring system. So there are just numerous applications that are uh, some of them are conventional, which already existed, and some of them people are coming up with new and new technologies every day and new applications of ITS every day to make our roads much more safer and much more sustainable. So the first one that I was talking about, that's called the blind spot detection. So in the blind spot detection, so uh, if you have ever driven a car, you would realize that there are many parts in your car due to which you're not able to see the entire surrounding area of your vehicle. So there are these A pillars which are there in the front of the vehicle, due to which there is a blind spot that is created. Then the side mirrors and the rear view mirrors that you have, they also don't give you a complete picture of the vehicles in your surrounding. For example, this two-wheeler would not be visible to a driver, and this car would not be visible to a driver in the rear view mirror or in the side mirrors of the car. In such scenarios for blind spot detection, ITS works very well. And in the new cars that are coming after 2020, 2022, since BS6 has been implemented, the along with the BS6 improvements in cars, the technological advancements in the cars have also increased many folds. So several cars are now coming with these blind spot detections. So earlier versions of cars used to have just parking sensors where if something came close to your rear bumper, your car would beep. Now you have 360-degree sensors where if anything is in your blind spot and if any obstruction or any vehicle or any passenger or any pedestrian is there, again the driver will get alerts. The alerts can be for pedestrian, that's called a pedestrian detection system. It could be an alert in the form of a beep, it can be an alert in the form of a flash, there can be various types of alerts. It can also be coupled with AEBs, that is advanced emergency braking. So once it is not just detection and alarm, it is also taking control of the car to have automated emergency braking to ensure that the vehicle does not hit into a pedestrian or a bicyclist. So these systems already exist. So if anybody is aware of ADAS level 2, that is advanced driver alert systems, which are of level 2 generation, which are coming in cars in this generation. So you have various cars that have launched ADAS level 2. Honda has launched ADAS level 2. The cheapest one that you can find is in Honda Amaze. Then you can see ADAS level 2 in Tata cars. You can see ADAS level 2 in Mahindra cars. And obviously, the foreign brands have had ADAS level 2 for a very long time. I'm talking about the Indian manufacturers. So ADAS level 2 has also come into the Indian market, and Indian manufacturers have also launched ADAS level 2, which has all these capabilities that I'm talking about. Okay. Then pedestrian traffic signals. So in most of the Indian cities, we either don't have pedestrian traffic signals. Sorry. And even if we do, then we don't really take our pedestrian traffic signals very seriously. Okay. So a pedestrian traffic signal is generally coupled with the vehicular signals. And whenever the vehicular signal turns red, the pedestrian signal turns green. That's about what we do with the pedestrian traffic signal. But if you go abroad, if you visit Europe, if you visit UK, if you visit USA, and several other such countries where pedestrians are given a lot of importance and preference, you will find that there are many different type of traffic signals which we don't have in our country. Okay, and these are new, but these are new for us, but they're quite old and they're quite useful, and people are used to them, and they're being used for decades now to ensure better pedestrian movement and better pedestrian safety. So we'll just look at a couple of them. So one is an automatic pedestrian detection system where, with the help of either IR cameras or with the help of normal cameras, where we have computer vision with the help of which one can detect that there is a pedestrian waiting or a pedestrian crossing, and accordingly the pedestrian traffic signal can be uh, can be changed or can be exercised depending upon the detected pedestrian in the waiting area or in the crossing area. Another form of pedestrian detection, the earlier one that I was talking about, this was detection using cameras, either infrared cameras or computer vision cameras. And the second one is with the help of a puffin signal, where a puffin is nothing but pedestrian user friendly intelligent system, where it's either an infrared detector or a pressure sensitive mat that is used to sense that a pedestrian is waiting at a crosswalk to cross the road. As soon as a pedestrian is detected, the signal cycle automatically is altered, and as soon as possible, a green phase is given to the pedestrian to safely cross the road. Okay. Then one of the oldest types of pedestrian crosswalks is the pelican signal or the push button signal. So if you see here, you will see a small box on either side of the crosswalk, and as a pedestrian, if you want to cross the road, you simply go and you push a button here or here, and after the push of that button, again the signal cycle will be altered and a green phase will be given to the pedestrians who have pushed the button to cross the road. So this technology is called pelican crossing or the push button system. Again, at very few places in India this was implemented. I saw this once in Delhi near the India Gate, but it was not successful. Two reasons: one, people were not aware what this is for, and secondly, even when the signal for the pedestrians was turned green, the motorists and the vehicles did not actually stop to allow the pedestrians to cross. So for these were the two observations that we had for understanding why pelican crossings did not work. But that being said, these work beautifully in Western countries. I myself have traveled and used them, and if we press the button, so maybe within the next 5 to 15 seconds, we get a green phase, and vehicles do stop and allow you to cross. Next is uh, there's a smart pedestrian crossing in Spain. So what they have done is, in the city's main accident black spot areas, they have installed these smart crossings, and this has helped them to prevent accidents, particularly in the dangerous parts of the city center. These traffic lights are equipped with displays that turn amber signal if a pedestrian is approaching the crossing, and when a vehicle is driving down the street at over a speed of 30 kilometers per hour, the red light warns the pedestrian of the danger. So it is informing both the vehicle as well as the pedestrian about a potential safety risk that might occur because of the interaction between the pedestrian and the vehicle. Okay. Then there was a very innovative project that was there in London that was called the Line of Sight project. So what they did was, here they installed a strip of LEDs which would light up when the pedestrians were crossing the street. So you might have observed, especially during night time after the sunset, when pedestrians, it becomes very difficult to see the pedestrian. You, even if you want to stop for a pedestrian during night time, if there is not proper visibility and street lighting on the road, then it becomes very difficult for the drivers to see the pedestrian. And if they don't see the pedestrian, that often leads to a lot of safety risks and accidents and even fatalities. So this project, what they did was they again installed some sensors, and as soon as some pedestrians stepped on the crosswalk, these red colored LED strips would light up, which will definitely grab the attention of the driver, and the red color would tell them to stop or at least slow down. Okay, so this red light warns the cars anytime someone steps on the crossing, and once a pedestrian crosses the street, they flash and then simply turn off. So then, if there is no pedestrian, it would just simply look like a normal crosswalk. Then again in London, there was another technology that was called the traffic tech switch pad. So this pad detected whenever a pedestrian stands on it, and it sends a signal to the traffic control lights, and the signal phase of the signals, it is altered whenever a pedestrian is detected. It can also cancel the signal if the pedestrian steps off the pad. The device can even detect the direction in which a pedestrian is walking, because it contains multiple rows of buttons that are activated individually. So this is like a pressure sensitive pad which detects if there is a pedestrian and in which direction the pedestrian wants to go. Then there is the Starlink crossing. So this was also again a very innovative way of ensuring safety of pedestrians. So here, if you step on the curb side where you want to cross the road, a crossing will automatically appear. Okay, so it's a plain road, and as soon as a pedestrian comes, this crossing appears. So if a crowd wants to cross simultaneously, the crossing widens, and if someone staring at a smartphone veers into traffic, the warning lights illuminate around them. These markings look similar to those that are usually painted on the road, but because they are created with LED lights, they can continually change. So this Starlink crossing, this can be achieved by either with the help of LEDs or even with the help of projectors. Projectors would work only during night time, but that is where the most of the safety issues take place. So a projector would simply project a crosswalk and the required illumination onto the road, which would allow for a safe passage for the pedestrian. Okay, coming back to the advanced driver alert system, that is ADAS. So ADAS has evolved over decades. Okay, ADAS earlier was simple ADAS, then came ADAS level 1, then ADAS level 2. Now ADAS level 2 is in the market. It is available, commercially available in India as well by Indian manufacturers. But just to look at a brief history, so the driver assistance system in the first place aims at supporting the driver task of preventing the vehicle driver from getting involved in an accident, or at least reducing the severity of the impact. These can assist the driver, these can inform and warn the drivers, and sometimes even intervene in the actual driving process. Okay, so when we say intervene, it means it can take over the controls of your car. Fiat launched the first haptics in 2008. NVW was introduced by BMW in 2008. Then PDS has been launched by Volvo in 2010 and 2011 models. And Mercedes introduced DDM in 2010. We will look at some of them. We even have some videos to show you. So this procedure can be influenced by awareness campaigns, fiscal measures, and many other inclusions and ratings. So what an ADAS does basically, it detects objects, it detects hazardous road conditions, it classifies objects, and then it either stops or slows down the vehicle if required. So as I said, it is not just detecting objects and creating alarms. It detects objects, and if it finds that there is a hazardous condition developing, it can take control of your car, and it can stop your car, it can slow down your car, it can steer your car to make sure that minimum amount of damage occurs. The first attempt is to entirely avoid the accident, either by braking or by maneuvering, and if that is not possible, then at least the idea is to minimize the impact as much as possible. So these have wide applications in blind spot monitoring, lane keep assistance, forward collision warning, and parking assist. What are all these? So blind spot monitoring we have just seen. Lane keep assistance is that if your vehicle is equipped with an ADAS level 2 and you have turned on the lane keep assistance, your vehicle will keep on driving in the same lane. And if for any reason your vehicle uh, tries to sway out of the lane, the steering will give you a haptic feedback. It will vibrate and it will slightly turn itself to keep your car in the traffic lane. That is lane keep assistance. Then we have forward collision warning. So what forward collision warning does is you can set a distance that you wish to maintain with your leading vehicle. So if there's a vehicle moving in front of you, you can maintain a safe distance with that vehicle, where if that vehicle comes too close to you, the ADAS system will give you a warning, and if required, it will also automatically brake to slow down or stop if the vehicle comes too close to your bumper. Then with these technologies, you might have seen some of the advertisements these days that cars can now park themselves. So that is nothing but ADAS level 2 in action. So parking assist is there in ADAS level 2, where the car can steer itself into a parking area and park itself. So an ADAS architecture typically comprises of cameras and sensors. So these include multiple cameras, multiple radars, including even lidar if required, and it has uh, various sensors like navigation sensors, accelerometers, gyroscopes, everything, which help in identifying and classifying various objects in the surrounding area of the vehicle. Once all this information is gathered by these sensors, an ADAS controller takes decisions about braking to avoid collision, about adaptive cruise control, about lane departure warning, and many other applications. These can also take control over the systems of your car. That is, it can brake, it can steer, it can change your suspensions, it can change your powertrain systems and your battery systems. So, an ADAS is basically trying to automate your car to some extent to make your driving experience much more safer and smoother. So the various functions which an ADAS can do, there is adaptive cruise control, blind spot monitoring, lane departure warning, lane departure correction, collision prevention, road prediction, traffic sign recognition, parking assistance, attention assistance, and night view assistance. The various sensors that are there in ADAS systems nowadays. There is a long range radar, there is a short range radar, there are stereoscopic cameras, there are night view cameras, there are ultrasonic sensors, parking cameras, map servers or GPS inbuilt into the cars, and the drive dynamic sensors. So many technologies together bring us the ADAS level 2, which is available today, and we will look at a few of them. This is the lane departure prevention system that I was talking about. So if your car is moving in a lane and it tends to, sway out of the lane marking, then the the car will get a warning, it will get an alarm, it will get a haptic feedback on the steering, and then the car will take control and it will bring your car back into its lane. Okay. Another application is advanced vehicle control. That is, we just saw that by another name. It was forward collision warning. So in this, what it does is basically cruise control is something which was there in ADAS level 1 also. So you can set a speed at which your car can keep moving automatically. You don't have to accelerate. But the problem is that if there is a vehicle in front of you, the car will not know when to slow down or stop. You will have to manually brake. To solve that problem, the ADAS level 2 now has AVACS, that is Advanced Vehicle Control and Safety Systems. So what it does is it detects how far the leading vehicle is from your vehicle, and depending upon a distance, a safety distance that you have set, if the vehicle comes, if the vehicle brakes and comes too close to you, the your vehicle will also automatically start applying brakes and slow down with the leading vehicle. Okay, so this is these are anti-collision devices or advanced vehicle control safety systems where the cruise control and the anti-collision devices, they work together to basically take partial control of your car, where they can even accelerate automatically and brake automatically to maintain the same distance with the vehicle in front of you. Then there is electronic vehicle stability control, EVSC. So this is a very interesting technology, and this was, to the best of my knowledge, it was first introduced by Mercedes. So what happens is that when you are when, so let's look at this example. So let's say I am this yellow car, and I see that there is a vehicle that has broken down, and I have to suddenly change path. So if at a high speed, if I suddenly take a right turn, my vehicle can spin out of control and it can run off the road itself. An EVSC system, what it does is, it does not allow your car to uh, go off the road or to spin like this that you can see in this image. It will make sure that your car smoothly transitions even at a high speed and stays on the road. It has yaw rate sensors which control the lateral acceleration of your car and make sure that such scenarios do not occur. We'll see a short video of EVSC that will give us a very good idea what an EVSC system does.
As you drive, many forces act upon your vehicle.
Is the is the is the video audible also?
Yes,
Can you
yes,
hear?
yes. It's audible and it's visible also.
Perfect, perfect.
As you drive, many forces act upon your vehicle. You probably feel some of them in everyday driving, like when you lean toward the side in a corner. When you turn the steering wheel, your car doesn't just move to one side, it actually rotates about a vertical axis. Under some conditions, the car might rotate too much or not enough, like when you swerve to avoid an obstacle, take a curve too fast, or encounter a slippery road. This is why Mercedes-Benz invented ESP, the Electronic Stability Program. ESP's network of sensors, one of the most advanced in the industry, continually monitors how well the car is carrying out the driver's orders. ESP compares your steering inputs to the speed of each wheel and the car's rotation. Within milliseconds, ESP can sense if the car is not following your intended course. When you quickly steer to avoid an obstacle, the car wants to continue straight ahead. ESP brakes the inside rear wheel. This creates a rotational force that helps the car steer where you tell it to. As you recover, the rear of the car can spin out. ESP brakes the outside front wheel to help rotate the car back on course. If necessary, ESP can also reduce the engine's power to help restore control more quickly. When the laws of physics meet human nature, ESP helps keep you on course and in control.
Okay, so I hope that gave a clear idea of what an ESP is and what a vehicle stability control system does. So it's the common commercially used name is called ESP, and the technology is called EVSC, Electronic Vehicle Stability Control. Okay. Some another technology which is now very common in cars. It was there in it has been this technology has been there in cars in India for the last decade, and now almost I don't think there is any car which comes without ABS. So ABS is nothing but anti-lock braking system, and I have seen many people don't understand what is ABS and what ABS does. So uh, this this small image, this explains basically what ABS does, but I think better than this image will be another video with the help of which I can probably demonstrate the importance of ABS in vehicles. Let me just play the next video.
When applying full brakes in critical situations, or when braking on slippery roadways, the wheels can lock. The vehicle can no longer react to the driver's steering because the locked wheels can no longer convey the optimum braking power and necessary turning force to the street. It hence becomes nearly impossible to evade an obstacle. ABS, the anti-lock braking system from Bosch, prevents locking of the wheels. ABS ensures that the vehicle remains steerable and stable while fully applying the brakes. The ABS control unit also continuously monitors all wheels by means of wheel speed sensors. Should the system recognize that a wheel is locked, ABS immediately intervenes and systematically regulates braking pressure. ABS can regulate each individual wheel within milliseconds. With the electronic anti-lock braking system, a sort of electronic intermittent braking, ABS achieves stability and steerability with the shortest possible braking distance. Let's have a look at the ABS benefits in practice. Full braking at 100 kilometers per hour. With ABS, the braking distance is significantly shorter and the vehicle remains stable. Full braking in a curve. Without ABS, should the wheels lock while applying full brakes along the curve, the vehicle can no longer be steered and slips out of the curve. With ABS, you have the vehicle under control and you can steer systematically. Full braking and swerving. Should the braking distance not suffice, the driver must swerve to evade the obstacle. Without ABS, the vehicle cannot respond to the driver's steering attempts. With ABS, your vehicle remains steerable and stable. A collision is thus avoidable. Full braking on different surfaces. Traction on lanes may vary due to volatile weather, dirt, and foliage. When fully applying brakes without ABS, the vehicle can quickly become unstable. With ABS, the vehicle remains stable, even in this situation, with an optimal braking distance. In everyday life, these abilities of ABS are vital. ABS prevents the locking of wheels when applying full brakes. It shortens your braking distance and ensures that the car remains steerable and stable. ABS is essential for your safety. Safe braking with ABS from Bosch.
So I hope this video cleared a lot of ideas about what ABS does exactly. So there are three basic points. One is it reduces the braking distance considerably. Second, it allows you to steer even while you are braking. So if ever you have applied emergency brakes, if you apply the brakes very hard, your tires lock. And when your tires lock, you're not able to steer your vehicle. With ABS, you can steer your vehicle even when you are braking. And third is when you have a slippery surface, that could be rain, water, snow, anything. Braking on such surfaces, hydroplaning occurs, and again your vehicle loses control. With ABS, it does not allow your vehicle to lose control. and all this is achieved just with the help of a simple technology where the brakes are not applied continuously in an ABS system. It is triggered on and off, on and off, on and off at a very high frequency, which allow us all these three benefits with the help of ABS. Another very interesting video of ABS is ABS in two wheelers. So this is again something which is new. Few people know it. Some of the advanced bikes, even bikes like Royal Enfield, are now coming with ABS, and definitely sports bike have been having ABS for a very long time. So let us see what is ABS in two wheelers and what it can do. So you would have understood by this video that ABS on two wheelers is also so significantly important because two wheelers are most vulnerable road users, prone to most of the fatal accidents, and something like an ABS system can really ensure that at least there are no runoff crashes with two wheeler users. Okay. Then intelligent speed adaptation. So again, this is something which is relatively new, and you may not find this completely implemented in Indian cities. One of the reasons is not that the new cars are not equipped with the ADAS system, ADAS level 2 systems. They are equipped with intelligent speed adaptation. The problem lies when uh, the city's infrastructure should also be available to interact with your car and tell it the speed limit on that particular section of the road. To give you an example, if your car is moving at a speed of 60 kilometers per hour and suddenly there is a traffic sign, a speed limit sign of 30, your car will automatically read that sign, detect that the speed limit is now 30, and bring down your speed to 30 kilometers per hour, or plus minus a few kilometers per hour here and there, and make sure that you stay within the speed limit. That is intelligent speed adaptation. Then speed violation detection systems are now very common. I am sure everybody must have either seen or themselves been subjected to a speed violation challan. So these challans are done with the help of video cameras and even using radar guns, with the help of which they detect the speed of the vehicle as well as the number plate of the vehicle, and challans are created for vehicles which are exceeding the speed limit. This is an example. You can see it gives the location, it tells in which direction the car is moving, in which lane the car is, the speed at which the car is moving, and what type of challan has been created. Similarly, another example. So with the help of radar guns and ANPR cameras, that is automatic number plate recognition cameras, this is a system which is very well tried and tested, and is now used almost everywhere in cities as well as on highways, and very widely used to avoid or to catch people who are overspeeding. Okay. Next, there was one more interesting application which talked about ignition locking system, which is also called alcolock. So basically, the traffic police people who have those alcohol meters with them, you might have experienced that a traffic policeman may ask you to blow into a device and it checks your alcohol level. Similar kind of devices were introduced for cars, and they were connected to the ignition of the car. So if you have had alcohol, if you've consumed alcohol, the car will not start if you have alcohol detected on your breath. So the problem with this was that somebody who wanted to break that rule and wanted to drink and drive, they would always ask somebody else to blow into this device and then they could drive. But still, nevertheless, it was an interesting application which was introduced and it worked to some extent, but it was not a foolproof system, so discontinued. Then seatbelt reminder. So this all of us have seen, starting from BS4 cars to BS6 cars now. So BS6 cars had seatbelt reminder for the front passenger vehicle and the driver, and now the BS6 Stage 2 cars has seatbelt reminder for all the 5 seats or 7 seats in the car. So if even if the rear passengers are not wearing a seatbelt, the car will continuously keep on beeping for the seatbelt reminder, and unless you buckle in the seat belt, the alarm will keep on going. So that is the seat belt reminder. Then there's also a black box for cars. It is more or less similar to the black box that we hear about in aeroplanes. So this has all the vehicle kinematics data, and with the help of that vehicle kinematics data, the black box can be used in the case of some issue or some accident or fatality, where this data can be used to assess what actually happened. Then the, the road safety is not just about using ITS or sustainable solutions to reduce accidents. There's a lot of behavioral issues that are also there. That is the driving behavior of people, how they drive in different situations, which also leads to a lot of issues related to road safety. Like, for example, people with different age groups tend to drive differently. So slightly the younger lot of people, the teenagers, the recently people who recently get a new license, the age of 18, 19, 20, it has been observed that they generally tend to drive more aggressively as compared to experienced drivers. Then different education levels may also impact your driving abilities or driving characteristics. Experience certainly makes a lot of difference. Then distractions. So there are so many distractions on the road. There are billboards, there are passengers who are talking to each other, there are passengers and drivers who are texting or calling while driving. The in-vehicle entertainment systems itself now are so complicated that they have become a distraction. And fatigue and music, all these are distractions which again can lead to road safety related issues. Then there are highway characteristics, different types of highway facilities, traffic flow, functional classification of roads, road markings. There is the environment, that is the type of weather and the type of lighting, which can lead to a change in the driving behavior. Enforcement, how strict the traffic police is, that can lead to a change in my driving behavior. Then surveillance and of course vehicle characteristics, what kind of vehicle do I have, what is the age of my vehicle, that will also affect my driving abilities. Then strategies to improve driving behavior. We want our drivers to be more responsible. How can we do that? We can create driver behavior profiling and rating systems. We can have usage based insurance scheme. We can have eco driving rating criteria, and we can of course add ADAS, that is advanced driver alert system. So what is driver behavior profiling? So Ellison in 2015 defined a driver behavior profile as a normalized score of driver behavior, which serves as a proxy for assessing crash risk by combining the number of measures of risk on a common scale across the drivers. So, what this basically does is cars are fitted with a GPS device which captures all the kinematics data of the vehicle, that is speed, acceleration, deceleration, jerk, yaw rate. So all these information is captured and monitored, and it is transferred to a server from where it is then analyzed and drivers can be rated. So if somebody overspeeds quite frequently, they can be classified as an aggressive driver. If somebody accelerates very quickly or does harsh braking, very hard braking quite often, they can also be categorized as aggressive drivers. If somebody changes the lane very often, that is zigzag driving, that person may also be treated as an aggressive driver. So, based on uh, algorithms like these, you can develop a driver behavior profiling or a rating criteria, and that can then be used for controlling the way drivers behave. So one of the easiest way to do, and one of the ways in which it is being done in Western countries, is the motor insurance that the premiums of the motor insurance that we pay, they are linked to how we drive. So there are three motor insurance schemes which are there in Western countries. One is pay as you drive. So this means that if you drive your vehicle more, then you pay a higher premium, because the more you drive, chances are that the chances of an accident occurring automatically increases. So there's one person who drives their car maybe just 1,000 kilometers in a year, as opposed to another person who drives their car maybe 20-30,000 kilometers in a year. So obviously the insurance premium for the person who is driving their car 20-30,000 kilometers in a year should be higher. That is PAYD, pay as you drive scheme. Then you have the PHYD. PHYD is pay how you drive scheme. So in the entire year for which you have the insurance company will monitor your speed, your acceleration and deceleration. And at the end of that year, it will assess how did you drive. So if you drive responsibly and if you drive within the speed limit and you don't drive aggressively, your premium will be lesser. And if you're overspeeding and if you're driving aggressively, your premium will be higher. The third one is manage how you drive. So this is the same thing but in real time. So in this case, every time you are speeding, every time you're doing harsh acceleration or harsh braking, alerts are generated and your premium automatically changes. Advantages: this can be used to reduce traffic congestion, reduce energy consumption, and significantly reduce air pollution. There are already several companies that are offering usage based insurance schemes. In India, it has not started yet, but it may just start any day. The system architecture is ready, the vehicles are ready. It is just the insurance companies who are waiting to test and validate the system, and integrate your motor insurance premium with your driving behavior profile. Then there is eco driving. You might have seen eco driving in two wheelers and in cars. So, eco driving, what it does is it controls the rate of acceleration of your car. So, if you don't accelerate too much, you will not brake too much either. And it has a significantly great impact on how much fuel you are burning and how much carbon dioxide you are emitting. So, this is something which really helps the environment, and it helps transportation sustainability in a big way. But the thing is that generally drivers do not follow eco driving, so vehicles now have inbuilt eco driving modes. Then, as I said, there are various devices for control collecting such driver behavior data. There are radar sensors, onboard sensors, GPS data loggers, cameras, GPS devices. There are many such things. At my institute at BNIT, we have several of these, and we've done various studies which are related to uh, traffic lateral shift. Like one of the studies was traffic lateral shift, where we collected data at different locations, and basically what we wanted to assess was, yes, this we wanted to assess the longitudinal gaps between vehicles and the lateral clearance. Lateral clearance is what is the lateral gap between them, and what is the lateral distance that they're maintaining with the median or with the curb. So this tells us again how many times people are driving very close to one another, how many times they are changing lanes. So this can be a very good way to understand aggressive behavior of drivers. Okay, another problem that we took up was helmet detection of two wheelers using image processing and machine learning. So we are all aware that two wheeler riders do not like to wear helmets for various reasons, but we all know the importance of why we should wear a helmet. So we used image processing and YOLO V4 at that time when we developed this, and we wanted to identify from the city's CCTV video feed. We wanted to identify whether people are wearing the helmet or not. So first we did vehicle detection. We identified two wheelers. Then we cropped the image to just keep the two wheeler and the number plate. And with that, you can see another vehicle where the person is not wearing a two wheeler. So we cropped all these images of two wheelers, and two wheelers with helmets and two wheelers without helmets. And after getting those images, we then identify the region of interest. That was usually the upper part of the image, that is 1/4 part of the image, where only the head was captured. In this head, then we created a data set like this, that is with helmet, with helmet, with helmet, without helmet, with helmet, with helmet. And we uh, trained this machine learning algorithm to tell it in which cases person is wearing a helmet and in which cases the person is not wearing a helmet. In the entire data set, we used over 3,000 images, and we used almost 2,000 images for people who were wearing a helmet, and 1,200, 1,300 images of people who were not wearing a helmet. And we validated this data set, and we were able to achieve an accuracy of almost 80%. And this was with the help of just 3,500 images. If we want to build this properly, we can increase the data set and we can have much better accuracy. Another device that we have, it is for vehicle classification, speed and trajectory. So here we have developed a device which can detect and classify vehicles like this. Then I'll not get into the details of homography transformation and how it works. But this is the device. This is an in-house device that we have made. It can collect all the traffic data. It can classify the vehicles. It can count the vehicles. It can calculate their speed. It can calculate all their kinematics, speed, acceleration, deceleration, and lane change behavior, everything. This is a deployment of the device. And just I think I might be having a short video. Maybe that will give a better idea. Yeah. So you can see in the region of interest, you can see that vehicles are detected. There's a bounding box that will come around the vehicle like this, and all the speed profiles classification of the vehicle will be done. Okay. This device also gives outputs like trajectory output of the vehicle. So if a vehicle is moving in a trajectory like this, a trajectory is plotted. It gives the speed profile of the vehicle, and this can also be used to create acceleration profiles, deceleration profiles. Endless things can be done with this data. Okay. So the simple question that we have with us is, do we have efficient plans to reduce and recycle the various tons of wastes and emissions that are being created by these transportation issues? Can we utilize the existing resources to meet the needs of the present generation without compromising the needs of the future generations? So urban transport sustainability basically talks about the same concept, that is judicial use of resources in our day-to-day transportation needs. Okay, so transportation is one of the biggest contributors to uh, global warming and carbon footprints in the world, and there's a very very strong need of sustainable transportation planning and execution. Strategies for sustainable transportation include three basic pillars. One is vehicle and fuel technologies, demand management, and road operation improvements. In road operation improvements, we talk about traffic flow changes, intelligent transportation systems, driver educations. In demand management, we talk about land use strategies, pricing strategies, and model substitutes to give people more alternatives instead of private cars. In vehicle fuel technologies, we talk about new fuels, new vehicle technologies, and boosting of efficiency of vehicles. Okay, I will skip through some of these slides. I will just come towards the range of possible solutions that we have. Okay, so policies for sustainable transportation and road safety can make a huge difference. Policies can be short term policies like parking fee regulation, vehicle health certificate and registration policies, and vehicle ownership policies. What is parking fee regulations? So, in a congested commercial area, if I increase the parking fee to a very high amount, it discourages people to use private vehicles. People will find alternate ways to come to the commercial area. Then vehicle health certificate and registration policies, they are already being implemented very strictly in Delhi and even in other parts of the country. In Delhi, it's 10 years for diesel vehicles and 15 years for petrol vehicles. In other parts of the country, it's 15 years for all types of vehicles. But if you want to extend the life of your vehicles beyond that, in Delhi, it is very, very difficult. In rest of the country, you can get a vehicle health certification, and if your vehicle is really in a good condition, only then you're allowed to further extend the life of your vehicle. Then medium term policies include congestion pricing and incentivizing carpooling and car sharing. So congestion pricing is something that if an area gets too congested, we can levy an additional fee or a tax for entry into that area. That's congestion pricing. Then incentivizing carpooling and car sharing. So if somebody is carpooling or car sharing on their day to day trips, that is their work trips or education trips, we can find ways to incentivize them. Long term policies include, should we make flyovers to ease congestion? No. Flyovers don't solve the problem of congestion. They only invite more traffic. It will solve the problem for a couple of years, and after that, again, it will lead to more traffic. Instead, we need to promote and provide adequate public transport infrastructure. We have to ensure sustainable accessibility modes to all the public transport systems, and we need to implement land use transport policies to reduce the travel distances in cities. We need some out of the box policies like wherever possible inland waterways for passenger and freight. So the world's longest river cruise, Ganga Vilas, is from Varanasi to Dibrugarh. We already have that. Autonomous vehicles for freight and sustainable city mobility plans instead of city mobility plans. Our choices also can make a huge difference. So if you just look at these images, here we see 200 people accommodated in cars. Without cars, they look something like this. If we put the same 200 people on bicycles, they look like this. And if you put those 200 people on buses, they look like this. You can see they occupy much less of road space, which automatically means that you are reducing congestion. Again, another example, same number of people in a bus, same number of people on bicycles, and same number of people in cars. So you can see how much of road space is occupied by cars. Lastly, understanding carbon footprints. So the average Victorian car, I mean the conventional cars that we have, they have the largest carbon footprints. So they're emitting almost 240 kilograms for 240 grams of carbon dioxide per kilometer that they drive. The top range EVs that we have, EVs are often called very sustainable and eco-friendly, but are they really? No. They are also emitting 209 grams of carbon dioxide for every kilometer. The reason is because the source of electricity is still fossil fuel. We have very less amount of energy that is being generated by renewable sources. So if we are still burning coal to generate electricity, EVs are of no use if we look at it from the perspective of sustainability. Then dual occupancy cars simply reduces your emissions by half. A motorcycle is even lesser. And if you see public transportation systems like trains, trams, buses are much, much, much less in terms of their carbon footprints. Okay, so our travel choices: use public transport for daily long trips, use bicycle or walking for short trips, use e-vehicles or hybrids as personal travel modes, but also ensure that the source of electricity is also renewable source, it's green. Choose cleaner fuels, avoid unnecessary trips, and avoid idle running of vehicles. With this, I will conclude my session. And if there are any questions, queries, or anything which somebody would like to discuss, please most welcome to ask me anything you want.
Sir, good afternoon.
I request all.
Sir, good evening, sir. Professor Khelde
Yes,
is
sir.
here. Sir,
Yes.
I wanted to add one question, sir. Like, if we want to conduct road safety audit for urban areas, is there any special body which is working for this kind of audit, sir?
Yes, so every road that is being constructed, it is mandatory to now conduct a road safety audit. So for highways, it has always been there. For urban roads, also now we need a road safety clearance on urban roads. So the problem with urban roads are usually not new roads. They will either be uh, an upgradation of a road, maybe some widening of a road, or some refurbishment of a road. So road safety audit uh, may always not be mandatory, but it is the road agencies who are owning the road. Like in case of Nagpur, it could be Nagpur Municipal Corporation or NIT, or it could be NMRDA. So they are the ones who need to conduct road safety audits and ensure that the roads are safe.
Sir, are there any special courses or any series of you can say guidelines we have to follow, or we have to conduct any kind of you can say practitionary course to become a specialized road safety auditor?
Yes, so for road safety audits, first is we have an IRC code, IRC SP88. So that is a very detailed code that talks about road safety audits and how road safety audits are to be done. Then there are supplementary codes like IRC 35, IRC 67, that is for road markings and road signages. There is IRC 119 for expressways. There is IRC 99 for traffic calming measures. There's the IRC SP99, which is there for uh, crash barriers. So there are many supplementary codes to IRCSP 88, which also one needs to know. And to assimilate all this information in one place, we have the 15 days road safety audit courses, which are run in various parts of the country. Few IITs run them, few NITs run them, we also run them, CRRI runs them, IAHE runs them. So it is expected that a road safety auditor undergoes that 15 days road safety auditors training certificate program, and it is not just a routine uh, training program. It is a very rigorous training program with a lot of field work, a lot of field audits, and at the end of that course you also have a detailed examination where you are expected to present road safety audit reports, as well as a subjective and an objective type of question paper that you have to clear. So that is the road safety certification course that already exists.
Yes, thank you so much, sir. Thank you so much. And your presentation was very much, well organized. That every point was elaborated completely in detail format, sir. Thanks a
Thank you.
lot, sir.
Thank you, Yogesh. Sir. Thank you so much. I think there's a question I can see in the chat.
Uday, sir, please ask other
Yes, sir.
participants if they
There
are.
is one question from the participant
Yes,
in
yes.
the message group.
I can see the question. I'll just read the question. So it says, what are the developments for the instruments like mobile apps practically useful for Indian people in view of selection of suitable route to be selected for particular O2D? Okay. So, like mobile phone applications, obviously, there are a lot of our mobile phones are already inbuilt with a lot of sensors, and they have all the abilities to even collect GPS data, kinematics data, and using that same data, what Google is doing is Google takes your location and it takes the location of everybody who is driving on the road, and it uses that data to actually give you travel times on the road. So, with respect to selecting a suitable route for a particular origin destination pair, so for that, Google, using the real time GPS data of Google users, it identifies what are the travel times on different roads, and then it gives you the best possible alternative to go from point A to point B. So that is how mobile phones are used to identify, select suitable routes for finding the best possible route between A to B. Anybody can develop those applications. It is not very difficult. The problem is that you will need permission from people to use their personal locations, location data and GPS data to build a system like that. Fortunately or unfortunately, all of us are Google users. Either Android phones we're using, or we're using Google accounts, and those terms and conditions which we usually accept, there one of the conditions also includes usage of our GPS data for uh, these services of Google. Okay, I hope I answered your question. Another question, sir: are we seriously equipped with the infrastructure that is needed for futuristic, present, sustainable traffic management? So, Mr. Jayesh, yes, I would say we are not completely ready. We are not completely equipped, but we are moving in that direction. So, for a completely safe environment, we need the ADAS system in cars along with the infrastructure in the city which can be used by that ADAS. For example, if you want to use the lane assist system, you need lane markings properly marked on the road. If you want your ADAS system to detect the vehicle speed limit on the road, then proper speed limit signs should be placed on the roads. So both the city infrastructure as well as the vehicle infrastructure both need to develop simultaneously. So the vehicle technologies are developing much faster. The city infrastructure in the context of Indian cities is not at par, but I'll not say that it's very far behind. Things are improving, and they're improving for the better. Hopefully, in another 5 to 10 years, we can expect an infrastructure system which can interact with one another, and all the things which look conceptual today, they will become a reality. Okay.
Yes, participants, any more questions? Sir, I have one question.
Yes,
So,
please.
since you have covered the topic of blind spot,
Yeah.
so how can we reduce this accidents related to the bike blind spot which are occurring in two wheelers?
Okay.
So there are solution for four wheelers. So what about two wheelers? I personally have faced that situation.
Yes, absolutely. So the technology still remains the same. The thing is that the sensors that are used for blind spot detection, they are the same whether it is a four wheeler or a two wheeler. The thing is that manufacturers of two wheelers, especially in the Indian market, their focus is on manufacturing the two wheeler at as low cost as possible. But when we talk about four wheelers, so we see a very wide spectrum of four wheeler manufacturers where safety is given some importance. So you do have all those sensors which can detect black spots and create alerts and alarms. The same sensors can be used in a two wheeler as well, but if those sensors and those technologies are brought to a two wheeler, the cost of the two wheeler will increase, and that would be a problem. That will be a problem for the manufacturers in terms of sellability. So maybe we might see those sensors in some high end two wheelers, but in the regular routine two wheelers that we see in the Indian market, it does not appear to have an application very soon.
Sir, is there any company who is using that technology like sensors and all for two wheelers?
Every car manufacturer today has that technology. For two wheelers, I have not seen it yet, but it's the same technology. It's the same radar sensors and the ultrasonic sensors that are there. They can be embedded to a two wheeler, and they will work the same way as they do for a car.
But currently nobody is using that.
No, no. At least to my knowledge, I have not seen.
Okay, sir. Yes, participants, any more questions? Sir, I think there are no questions from the participants.
Okay.
So, on the behalf of all the participants and Civil Engineering Department of ICC Nagpur, I sincerely thank you, sir, for this insightful session on road safety in a sustainable direction. The session was very informative, and thank you so much, sir, for sharing your valuable insights with us. Thank you so much, sir.
It was my pleasure. Thank you so much for inviting me. Thank you to YCC. Thank you to Yogesh sir and you for coordinating this session. And thank you to all the participants for listening patiently. Thank you very much.
Thank you so much, sir.
Thank you so much, sir. Good night, sir.
Have a good night, sir.
Good night. Good night. Thank you.
All the participants requested to don't leave the session. Next session will be start immediately.
Yes, participants are requested to stay here only because the next session will start sharp at 7:30.
Yes, sir. I will ask speaker to join the session.
आवाज आ रहा
Ready,
है
sir?
क्या? खरीदे सर?
Yes, yes, sir. I will ask speaker to join the.
हाँ, आवाज आ रहा है क्या मेरा?
Yes, yes. You are audible, sir.
ओ-
Wait for second, sir.
ओके. थैंक यू.
Sir, I send a message to speaker. If within 2 minutes he will not join, I'll call him to join the sir session.
ओके सर. ओके. ओके.
And
ओके.
if he joins, if he joins, you can start talking to him, sir.
ओके. उदय सर.
I tried calling him, sir. He did not pick up the call. We'll wait for 2-3 minutes and then again I'll call him back, sir.
Okay, sir. I think sir
No,
is joined. Sir is
I have
joined.
Yeah,
joined.
sir. John.
You wish I have
Yeah,
joined.
sir. Good evening, sir.
Good evening. Good evening.
Very warm welcome to you for this expert session, sir.
Yeah, yeah.
Uh,
Thank you. Thank you so
Professor
much.
Professor Hinge will introduce you, sir, and then we will start your session, sir.
Sure. Perfectly fine. So,
Yes.
so you are continuing your session. I mean, there was another session. It's just continuous. You were doing right.
Okay, sir. Yeah.
Okay. Okay.
We had just completed Professor Udit sir's lecture expert session on road safety,
Oh, nice.
and your session that is why I asked you to join at 7:25. Yes.
Perfectly fine. We can proceed.
Yes.
Huh?
Yeah, Hinge sir, you can take over now.
Okay, shall I start?
Yes.
Please go ahead.
Okay, okay, okay. So, good evening, everyone. I am pleased to introduce Dr. Gaurav Sil, sir. He is assistant professor in Department of Civil Engineering at IIT Indore. He holds a PhD in Transportation System Engineering from IIT Bombay, along with the MTech from IIT Bhubaneswar and BTech in Civil Engineering from West Bengal University of Technology. Dr. Sil's research focus on the road safety, geometric design of highways, driver behavior analysis, and intelligent transportation system. He has lead sponsored projects funded by SERB and IIT Indore, and sir has published a number of papers in extensively in the reputed international journals and conference. He is also an active member of professional societies such as TRG, IEEE, and WCTR, and has delivered several invited talks and keynotes lecture at the national and international platform. His work has been recognized with the Best Paper Award at prestigious conferences like TPMDC 2024 and TIPCE 2019. We are honored to have him with us today, and I now welcome Dr. Gaurav Sil sir to share his valuable insight. Sir, please.
Okay. Yeah. Thank you, sir. Thank you for this nice introduction. First of all, very good evening to all the organizer and the participants. And thank you for inviting me for this important workshop on sustainable energy and climate solutions. So I have been given, I mean, discussed a topic on. I hope my screen is visible to you. All
Yes,
of you.
sir.
Yeah.
Yes, sir. Yes.
So I'll just convert it to the slideshow mode. Before approaching that, I want to say this is actually the entire lecture is based on, or the presentation is based on the geometric design and the geometry of the roadways, whether it is a highway, whether it is a urban road, whatever it is, based on the geometric design. I will discuss initially. Just a minute. Okay. So I'm just turning off my camera for the ease in this your internet speed. Okay. So coming here, so if you see the topic of the discussion today is the safe, sustainable approach in road geometrical design. So there are various geometric component we should look into uh, and make it safe for the all the road users. What are the road users type of? First of all, you know the vehicular traffic. It can be a car, it can be a three-wheeler, it can be a two-wheeler. Along with that, there can be the pedestrian also. Okay, so there are various component. So if I summarize this today's lecture, what I will try to present, what are the existing engineering practice in the field of civil engineering or highway development, like our national highways authorities of India and more. What are the guidelines we follow as per the conventional geometric design technique? And the main motive is that how make it safe and sustainable based on the feedback taking from the drivers. how we can take the driver behavior into the design. Currently, the design practices, it is a deterministic approach. We usually don't consider the driver behavior explicitly on that. So I'll be discussing on that. So coming through that, starting about the introduction, if you see the first figure here, what I show that 14%, what I see the 14% of the global crashes are what happening in India. And if we go here, the value 35% is indicating that 35% of accidents, more than one third percentage of share of the accidents are happening in the highways. So this report is reference is provided NCRB and WHO 2023 as per their report. So what is happening? So today discussion will be based on highways. Okay. So coming forward, next motivation from these accidents are happening 14% share of global accidents happening on the highways. If we go further,
Sorry to interrupt you, sir.
yes,
Sorry to interrupt you. Whether are you changing the slides, sir? Because here the slides are same.
is it a title slide with you?
Yeah, yeah, yeah.
Yes, sir.
I have changed now. I am on introduction slide. You
Okay,
can't
okay,
see the
okay, sir.
introduction slide.
I thought you must be changing something, and here it is not displaying. So I
Yeah,
thought
no,
I
no,
should
no.
be
I
changing.
am in, currently I am in slide number 2. This is the introduction slide. Can you see that
Okay, sir. Okay,
introduction
sir.
slide?
You can continue. Yeah.
Can you see the introduction slide?
Yes, sir. First slide we are seeing with the title.
Yes, sir. Yes, sir.
No, no, no. Can you see the slide number 2?
No,
No,
sir.
sir.
Okay, just a minute.
That
Let,
when
let me
it
finish
goes
your,
into full screen. Yeah,
your
now it
Now
is.
visible. Now visible.
no, but I make it maybe. Let me see now. Can you see the second slide now?
Yes, sir.
Now is it moving?
Yeah. Second slide is there, introduction.
Introduction, yeah. So
Actually,
yeah,
what happens, sir? When you make it full screen, it becomes second window. So you have to again go back to the Google Meet and you have to present the second window, which is full screen
yes,
window.
yes, yes. Now
Yeah.
what I have done, I have shifted my second screen to here in the first screen. I think now it's
Okay.
visible to you. Hmm.
Yeah, now it is in second. You can just try switching on if you want.
Can you see the is it moving? This
Mm, No, sir, it is first one only. Second introduction slide. Yeah, now it is moving, sir.
can you see what you can see now? This Srinivas Shuttle, can you see?
In your introduction slide, we are seeing, sir, now.
So here there you can see the map of India.
Yes,
After that, another image. Can you see the 25%?
yes. Second image also we can see.
Second image. Now
We are on second slide, I think.
second slide. Now there is a third image I am showing. Can you see that? On the
Uh,
second slide only, how many image you can see now?
we are seeing 6 total images on the second slide.
Now can you see this driver, road safety, vehicle, road?
No, sir.
Just a minute.
Yes, sir.
Let me reshare. And I am just
Yeah.
resharing it. Just give me some time. So now can you see that I am moving my animations?
Yes, sir.
Huh? Now is it working?
Now it is working fine, sir.
Slide number 3. Can you see?
Yes.
Now, which slide
Yes, sir.
is
Now
moving?
it is
Right?
moving properly. Yeah.
Yeah, very good.
Yes.
Thank you.
Thank you
So,
so much.
yeah, thank you for letting me know. So now coming here, I was discussing about the motivation or introduction of this research, this topic. What I want to say here, if you see that, as I mentioned, around 14% of the global crashes are happening in India, and out of those, 35% are happening on the highways and expressways. So it is a matter of concern. Further, if you further go in depth, we analyze the data, and what we find that what we found that 25% of crashes are happening on the curve section, horizontal curves basically. And out of these fatal crashes, these are the death actually due to the accidents on horizontal curves. And almost, if you see surprisingly, 60 to 70% crashes are single vehicle road runoff crash. So if you ask me what is single vehicle road runoff crash, if you see the image at the bottom side, there is a yellow car, it is moving and going out of the control and crashing with the roadside object. What is happening here? There is, in this situation, the driver is only interacting with the road environment. You just understand, when the road is completely empty, there is no traffic. In that case, the driver, he or she will be influenced by only the road environment because there is no traffic. If then you put some traffic on the road, there will be another kind of influence of the traffic to eliminate that. Geometry is designed considering that road is completely empty and some driver is driving with their expected speed or with their desired speed, and with that desired speed, when they interact with the geometrical features, so how we can make it safe? So if we cannot consider, horizontal curve is the one part of the geometric elements. So today's discussion merely based on the horizontal curve. I am doing this research from last more than 7-8 years in that area. So I thought of discussing this part only. So vehicle are going out of control when they drivers do not interact with the road geometry and road environment, and they perceive, they misjudge, and they do some mistake and they go out of the carriageway. So these are the possible reasons. If you see here, drivers errors in speed adjustment and perception when they cannot interact properly with the road geometry. Similarly, directional control, their trajectory on the curve, that is one of the important factor. If you are driving at a high speed and we cannot properly maintain our trajectory, in that case there may be some situation, some stability issue, we can go out of the carriageway. So now these slides, if you see that road safety, it is primarily influenced by three major factors. Although I have already discussed it, again with this image I want to make it clarify to some of the audience. So this road safety or highway safety is, these are the three main stakeholders: driver, vehicle, like what are the vehicle, like we know that this ABS system, vehicle technology, it is actually automated. And another is road design. So this road design here, our civil engineering plays important role. How to design the road that can accommodate most of the all the drivers on the road, and they maintain the safety. Similarly, the vehicular industry, they consider that how we design vehicle that they can be properly interacting with road geometry or road environment as well as driver. So it is a complex system. But as we are civil engineer, we are studying on for the transportation safety, road safety. We will be looking into the factor. The study we do, we make the vehicle characteristic constant or fixed, and we try to understand how this road is going to impact the driver and make the road safer. So another thing, if we see that our Ministry of Road Highway and Transport, MOT actually, so we are rapidly converting our 2-lane highways and 4-lane highways to multi-lane highways. Once we convert to multi-lane highways, obviously our expected design speeds are going in higher side. But at the same time, when we design a facility for higher speed, in that case, obviously when the speed is higher, if there is some incident, most of the cases, the accident is going to be fatal. If speed is less, accident can be there, it may not be fatal. But as we are going towards the high speed facility, so we are going more towards it, the road not properly designed. If something insert accidents happen, that is going to be the most of the cases, the fatalities. That's why there is a very big spike we can see now current days. Once the accident is happening on the highways or high speed road or expressways, those are most are fatal. Although the vehicle technology, vehicular safety, inside vehicular safety with the airbag system, ABS systems, although we have the privilege of having the vehicular safety, at the same time this fatality occurs because of the high speed facility we are going at. But I am not saying the high speed facility should not be there, but at the high speed facility, how driver interact. So entire motivation is that to understand, to incorporate the driver behavior in the design. So I'll come one by one in those slides. So the classification road in civil engineering, when we in BTech, we are in second or third year, some institutions we do go through a study called transportation engineering chapter. Subjects there we see that there are primary, secondary, and tertiary system. Primary system we have our expressway and national highways. Secondary system we have our state highways, major districts road, other districts roads, village road. All these roadways are have different kind of purposes. Their expected speed are different, their land use pattern are different, their purposes are different. So on the same line, if you see the geometric design, what we see, one simple understanding I can see, when you see the speed versus accessibility. Accessibility means when the facility is access control. Suppose if you go to the top figure here, it is a collector street. You can see it is accessible from any side of the area. So any kind of vehicle can come here and they can fly over there. So there is more chance of interaction. Similarly, local street, you can see how can accessibility. Highways are less accessible and express are completely access control. Like any kind of one of a sudden from anywhere, the any junctions or any approaching road, the vehicle cannot come here. It is completely access control of kilometers. So in that case, when it is access control or expressways, freeways, your expected speed is going to be high with this curve, you can understand. Similarly, when it is not access control or urban street, your accessibility is more, but our speed is going to be less. But when the accessibility is less and speed is going to be high. So this is one of the logic behind this. And so as I discussed the various kind of systems of roadways, so the motive of this slide is to discuss you that IRC 73-2023, recently it has been revised. It is basically geometric design standard for non-urban roads. Similarly, come to the second book, this guidelines, if you see the manual and specification and standards for 4-laning of highways. So similarly, in the third one, IRC 86, it is for urban roads and streets, and IRC SP 99 is for expressways. So all the expressways, all the type of roads, whatever we have, their guidelines are different because of their intended use. So going forward, now I am slowly going to the geometric design part. What is geometric design? It is. Can you see my slide number 6 or not? Hello?
Yes,
Yes,
sir.
sir.
Geometric design is visible. Geometric design.
Yes, sir, it is
Thank you.
visible. Yeah.
I am just confirming it. Okay. So now geometric design, if you see here, it deals with the dimensions and layout of the visible image. Like initial, when I start my discussion, I talked about how the drivers are interacting with the road geometry or visible elements. It involves the shaping of visible dimensions, elements to accommodate the driver, vehicle, and also the traffic characteristics. It focuses on the positioning of the road elements as per the standards and constraints. Road elements means there will be horizontal curve, vertical curve, there will be intersection. There are multiple components are there or elements are there. I will discuss those things. The fundamental aim is to maximize the comfort, efficiency of traffic operations, safety and economy, and also minimize the environmental impact. As a civil engineer, when we develop any road or design any road, we should aim for this maximizing this parameter and minimizing this environmental impact. So now visible road element we discuss. What are the, I have just listed some of the visible road element under the different categories. First, road components, if we go, that pavement or surface of the road, the carriageway is the visible element, one element. That also has some guidelines. Similarly, shoulder, what are the extra widening is provided along with the carriageway on the both across the road, that is called shoulders, median, roadside object. Coming to the pavement marking also, like markings on the road, we have center line marking, lane marking, crosswalk markings. These all things are interacting with the drivers. Similarly, traffic signals, other signages, road alignment is another features like horizontal alignment, vertical alignment, roadside safety features. So in this lecture, I will be primarily talking about this road features, but there are many other components also. So now, As per IRC 73, if you see, this is the cross-sectional elements as I mentioned here also. So in this slide, you can see the cross-sectional element where this road, this is a 4-lane divided highway, cross-sectional elements where 7 meter is the carriageway width because 2 lane 3.5 meter, 3.4 meter both the sides, and paved shoulder and earthen shoulder. This is called as cross-sectional element. Similarly, another design parameter is side distance. So the minimum distance required to take some decision, that is decision side distance. Similarly, to stop your vehicle, it's called as stopping side distance. So these all are the geometric elements. Similarly, if you come in this drawing, this is
Session
actually,
Suraj.
hello, okay. Horizontal alignment and vertical alignment, what you can see in the topmost part, this red line, this is actually top view of the highway. Just one part I am showing, one section I am just showing you. This TS, if you see the TS means the tangent to spiral location, then SC means spiral to curve, starting of the curve, circular curve, and again CS means circular curve to spiral curve and spiral curve to tangent, how we fit the curve along the highway. This is the horizontal alignment. Similarly, if we want to see the level of the road, these are the actually level of the road. There is a curve, it is going down, there is a grade of 4%, and again we have another valley curve. This is a summit curve and valley curve. So these are the both components. One is horizontal alignment on the top half portion and vertical alignment of the bottom half portion. So these alignments we need to properly design so that coordination between horizontal and vertical alignment is proper. So in conventional design practices, this kind of, if you see the nature of the terrain, that plain terrain, before coming to that, design consideration should adhere to the IRC guidelines with design speed serving as a key control. This is called as design speed based approach, what we currently using. Okay, and it is also already it is depending on mechanistic properties of the vehicle. So this is a snapshot, or this is a table taken from the guidelines IRC 73/2023. So what are the minimum design speed, ruling design speed or minimum design speed required for different kind of terrain and different kind of cross-slope facilities. So what are the issues in India? We understand if we use these fixed values, the influence of mechanistics or mechanical properties of the vehicles is going to impact that design standard. Similarly, heterogeneous traffic condition in India, heterogeneous is going to impact non-lane discipline is going to impact enforcement law, high variability of geometry. That all things there are some issues to tackle those kind of problems. So as I talk about this horizontal curve, if you see, we all know from our class 2 standards also, when a vehicle is moving on a curve, it is experiencing a centrifugal force, which is counteracted by friction between the tire and the road surface, and this is called as super elevation. We also know that banking in our class 2 standard, but in civil engineering we call it the super elevation. So using this formula, we can directly estimate what is our expected radius for the centrifugal force. So here this coefficient value is given to us that for conservative side, we should consider this 0.15. And this, just for example, I am telling you, this 0.15 value is based on very, old value, based on the old vehicle characteristics, we use it. Okay, nowadays vehicle characteristics, tire characteristics have changed, that may have some influence. Once I proceed with my discussion, you will see that what is happening. And from this equation, we can derive any targeted value for a given design speed, like design speed slide I already presented to you. Now, coming to this, if you come here, what it is sentencing, the limit of lateral acceleration, this also can be called as side friction or centrifugal acceleration, above which a drivers or vehicle occupants first perceive the discomfort is called as or referred to as comfort threshold. That means what it is saying, when the lateral acceleration is going beyond a particular limit, at that time as a driver we feel some discomfort because of this more centrifugal force, and it is trying to push out from the carriageway and taking it as making a road runoff crash. So that is called as comfort threshold, and this is something related to this friction value. Just remember that. Now, as per what is our conventional guideline says, our conventional guidelines guiding us that on ready of horizontal curve, desirable minimum is 400 meter for rolling and plain terrain, and for mountainous steep terrain is minimum radius should be 1.150 meter, and absolute minimum is 250 and this value. Similarly, for different highway type, when the condition is like that, radius is less than desirable minimum radius value, whatever value is given here. So it that get maximum allowable super elevation. If you go back to the slides, so it is we are talking about here this R value, and similarly this E value and F value. E is the super elevation, what should be the super elevation, what should be the R, what should be the F. This is been guided by the guidelines. So these are the values are given. When the 2 and 4 lane highways values, when the radius is less than desirable minimum, we should provide 7%. When it is a more than desirable minimum, we can provide 5%. Remember, this guidelines is revised in recent revision, which has been done in this guideline 2023. And the friction value again it stayed same, that 0.15. So something we have got interesting to our research that I'll be showing at the end of this presentation. So assessing a highway geometry using the performance matrix. Now I am coming till now I have discussed what are the conventional practice, what are the book says, guidelines says, how we do. Now I am from this slide, I am moving towards to let you know how we can design the road using, obviously these conventional guidelines or conventional design will be there. The attempt is to include the driver behavior into the design process and how make it more safer. The using the conventional design already it is safer, it is a mechanistic approach, or using the physics, these things we are developing, but our research aims was to include some input, take some input from the driver behavior and make it further more safer and make our road human interactive way. Okay. So it involves evaluating the design elements like I discussed, lane width, vertical curve, curvature. It involves evaluating those parameters based on how they impact the traffic flow, safety, overall operational efficiency. And similarly, using the quantifiable measures like operating speed, comfort threshold. So how we can use this operating speed or comfort threshold or crash rates or travel time, these are some of the indicators. This indicator we can do some research, do some data collection and understand how the drivers is taking the what is their operating speed, drivers population. Similarly, for a given geometry, what are the comfort threshold they are facing. We are trying to understand those parameters and incorporate those parameters in the conventional geometric design. And finally, aim to identify the potential issues and optimize the road design for desired performance level. What are our desired performance level? Okay. So these are some performance matrices done by this slide is prepared by some of my PhD students. What we identified that if we talk about the performance matrices all over the world for different taking their response from the all over the world, we just submitted this, we have developed this. So highway safety can be evaluated using surrogate measure as well as a direct measure. Direct measure nothing but using the accident data and then analyze. And surrogate measure, highway consistency is a surrogate measure, and it can be further divided into two sectors. One is consistency through driver behavior, another is consistency through the geometry. Further, consistency to driver behavior can be broadly classified as speed consistency, dynamic consistency, driver workload, driver perception, and decision making comfort. And consistency to geometry, it consists of alignment consistency. Just to be noted, these are the area which has been identified from the research work all over the world. This is not limited. Beyond this also somebody can select the 5th, 6th or 7th component. The percentage of very less, that's why we didn't show it here, but these are the major components or matrices we use for evaluating the road based on driver characteristics. So if you see further, based on the speed consistency, you can see this around 61% of researches or studies has been done on speed consistency, followed by 14% on alignment consistency, 10% each on driver workload and dynamic consistency, and 5% on driver perception. So all these matrices can be used to evaluate the design result coming from the conventional design and then further give a feedback loop. So this is the background I discussed. Now one by one I will go proceed towards our research work. So first research work is on speed reduction and comfort threshold. This is there will be total 3 study I will be discussing. I think 3 or 4 study. Very concisely I am going to discuss here. But the entire study's discussion is on speed reduction and comfort threshold. The study 1. If you see here, I will be discussing tell you about the how we have selected the study site and collected data. This stretch is actually in the nearby Indore, Madhya Pradesh. So NH52 we considered it is a plain terrain. Along this stretch, total 58 curves, which has 27 left turning curve and 31 of right turning curves. Total 65 kilometers of stretches. We have studied where we studied our driver behavior, something like that approach tangent ATL when it is an independent tangent, a long stretch followed by a curve, and we ask our participant driver to drove through this stretch and they drive as per their natural driving conditions. So this is called naturalistic driving conditions. They are not said that we are going to do some experiment, so they are not influenced. So if you see here, when they are driving through this kind of typical image I am showing you, this kind of road, we can get how they are, for example, what is their driving speed, what is their comfort. So for a given radius, for a given deflection angle, for a given ATL value, we can model their driving behavior. So these are the geometric statistics, like delta is your deflection angle of the curve, this R is the radius of the curve, LC is the length of the curve, this length of the curve, and ATL, this AT actually ATL, approach tangent length, and E is the super elevation of the circular curvature. So this is the descriptive statistics. Whatever the 58 curve we have considered, it is giving us mean, standard deviation, minimum, and maximum values. So we have developed the instrumented curve providing 4 cameras. There are some GPS based devices. There are some some laser sensors also. I mean proximity sensor also we used, and we asked this instrumented vehicle. Total 34 participant driver were asked, and we captured their speed and lateral acceleration profiles. Okay, so now speed reduction modeling for independent. TC means tangent to curve. This is tangent to curve. This is T, this is C. So that's why it is calling it TC transition for design consistency. So this is just a sample figure, sample profile, whatever we developed using our data. This is only for a single driver going through a specific curve, which driver ID was 15, and the deflection angle was this, radius was this, and all the geometric values was given. And for that we have estimated delta V. I mean, what is the speed drop? That is Vt max. So this is the Vt means maximum speed on the tangent. This is we recorded as 112 kmph, and immediately after getting into the curve, minimum speed we get here Vc mean as 94 kmph, and the subtraction of both is giving us the speed drop. So we are trying to understand how this geometric, characteristics of curve is going to influence their speed characteristics. Okay, and this PC is the starting of the curve and PT is the end of the curve. So these value we captured, and we try to understand the influence of geometry on the speed drop. So again, this is the your statistical parameter of the components of the 32 independent site we have considered, and these are the speed value observed, like operating speed at tangent, operating speed at curve, 85th percentile speed reduction. So subtraction of both, it is given here, number of trips at those. So this is the summary of the table. So after collating all this data, we're trying to develop some model and predict how, suppose this equation, if you estimate, this is the y equal to mx plus c simple linear equation. So if we want to understand y, what is the speed drop for a given geometry, suppose this geometry delta value and r value we are getting for conventional geometric design, and conventional geometric design giving us some value for delta and r. We put this value here and we predict what will be the speed drop. If we find that speed drop is very significant, in that case we can say that geometry is going to be a inconsistent, and that may create some road runoff crashes like situation. So based on this data point, what we have done, we have developed this kind of heat map. If you see, when the x-axis is consist of deflection angle and y-axis is the radius, and this scale is giving us, the yellow part is giving us the most speed reduction value, and this blue color, bluest most, it is giving us the less speed reduction value. So this is the region which is giving us the more inconsistent design zone. For example, if we are taking a deflection angle of 75 degree and radius of 200, so it is going to give us a huge speed drop like 60, 30, around 26 kmph, which is not desirable. If the road is consistent, a driver is not going to the speed that much drastically. You can something 10 up to 10 or 15 can be acceptable, but 26 or 30 is like something wrong is there with the geometry. That's why using this study we develop this kind of graphs. So the application of this study is, this study guides the controlling the geometric elements for design consistency and identify the critical tangent curve transitions. So this is the study number 1, and similarly another study we have conducted, that is study 2. This is naturalistic driving survey on earlier one. This one is done on 4-lane divided highway. This is we have done on 2-lane divided highway. Similar kind of setup we have used, instrumented vehicle, and where here you can see some descriptive statistics of the driver behavior also. Driver who are recruited, like their age, their experience, and their statistical descriptive statistics. So here what we estimated, earlier value we estimated del 85V. Del 85V means 85th percentile speed drop. Like suppose there is a 34 driver and 85th percentile of this 34 driver, what is the speed drop that we estimated here. And in the second study we estimated 85 percentile of 85th maximum speed drop. In this location, in this study, what we estimated, MSR is identified maximum speed on 300 meter, up to the 300 meters. So this PC is the starting of the curve, PT is the end of the curve, and before PC this is the tangent location. So what we have done, we gone through the upstream up to 300 meter, and we try to capture what is the maximum speed in that location. So that is up to 300 meter maximum speed we captured, that is called BT 300 max, and inside of the curve we recorded the minimum speed. Using this simple formula, the subsector we estimated the 85 MSR. So what we can see here, earlier was del 85B or del V85 and 85 MSR. You can see how underestimation we have done for in case of del V85 and 85 MSR giving us actual value, what is the actual speed, more speed reduction. So this is not underestimation. So using this form value we have estimated del V85 and this is 85 MSR. So these are the variables, again geometrical variables for this study, and we have developed this 85 MSR model because MSR giving us the more conservative side, because MSR giving us the higher value, and we always should design for the critical value. So as 85 MSR giving us the most critical value, that's why we consider to take it as a our measure. So going through that, the 85 MSR model, we have done some regression. We have run through some regression technique like forward and stepwise regression technique, backward elimination, and all subset techniques. Okay. So based on that, we developed this model, and we find that all this model and base model has been found from the all subset or backward model, backward elimination model. So finally, using this model, we try to develop some application oriented tool. So if you see, this is in the 3D view. Here we get three parameters, like here this model we selected, that radius G80. G80 means gradient of approach tangent, GC means gradient of the curve, and E is the super elevation. These are the three predictors we have obtained. And based on that, for a particular 3D plot has been developed for a particular G80, and actually it will be GC, not G80, 2.5%. Okay. So for this value, we developed this kind of, this axis is given us GC, gradient of curve. This axis given us R, radius value, and these are the super elevation value. So the green portion is green. Any point inside the green portion is giving us 85 MSR between 0 to 10. As far as the safety is concerned or consistency is concerned, normal practice rule is there. If the deviation within the 10 kmph, we can consider it as a consistent, or rather we can say surrogate safety oriented. This is the safe. When it is between 10 to 20, we can say this is something kind of fair kind of consistency. Green is good consistency, yellow is fair consistency, and further when with the red zone, it is given the poor consistency. So from this 3D image, you can use any point coming into this position. For that, you can directly derive what is the super elevation value, what is the gradient of the curve value, what is the radius value. For these given conditions, we can come up which is our consistent design and which is our inconsistent design. Okay, so we can pick any value, and then designer putting those value, this GC value, R value, this all input will be coming from, again I am saying this, all this value will be coming from which position? Again, if I go back to my slide, I will show this how this E value, GC value, from where we are getting those value. For example, just a minute, this, if you see this graph, this is a plan and profile drawing. So here we have the radius value, deflection value, and this is developed using the conventional design. So my intention to let you know that this is the horizontal alignment we are discussing about, and this horizontal alignment is designed using the conventional geometric design method. And from the conventional design method, we are getting the parameter like deflection angle, point of curvature, length of the curve, similarly other parameters, and taking those value from the conventional design, we will put it here. Just go back. What is the gradient, what is the super elevation value, and we try to understand how the driver will behave for that given conditions, which are the given conditions getting from conventional design. And we can understand, yeah, if we give some this kind of geometric design value based on the conventional design, that is going to be inconsistent, but if we give this kind of value, it will be consistent. So this is a further ahead, one more step going, combining with the conventional design. Okay, now this is the design stable final outcome we have proposed on this. So this cells, if you see, there are color differences, and what does this design table say? Predicted 85 MSR, that is 85th percentile maximum speed reduction in kilometer per hour. These all are the values, the super elevation values. It is starting from 2.5%, which is the minimum value of the camber, which is required for the rainwater passage, and 0.5% you have created each cell, 2.5, 3, 3.5. What are the super elevation values? And along this, we are having minus 2.5% gradient at curve, flat 0% gradient, that means completely flat curve, horizontal curve, and 2.5 a positive upgrade at the curve, gradient of the curve. And R is the radius of the horizontal curve. Again, I am saying this R is the radius of the horizontal curve, and when this radius, this curve, it is along a gradient. In that case, horizontal and vertical gradient, horizontal curve is on a gradient. So there are two things. This horizontal curve, when is a flat grade, what will be the value? When horizontal curve on a minus 2.5% of grade, what will be the value? And when horizontal curve of this radius on 2.5% of value, what will be the value? And these 20, 200, 250, 300, 350, all are the radius values. Okay. And for all this value, we estimated the 85 MSI. And what we see, this 1, 2, these all are the speed drop. So that's why these are green. That means these are on safer side. Suppose we are selecting a cell here, this 13. This 13 for the curve radius of a curve which radius is 300 meter along, and this curve is situated on minus 2.5% gradient, and this curve has a super elevation of E percentage, that is 4.5%. In that case, we are having 13 speed drop. 13 is somehow, we can say the consistency is fair. Similarly, when we come here, we can see that speed drop here for this condition 37. That means 200 is the radius of the curve, and that curve is on a gradient of 2.5%, and the super elevation here is 2.5%. So which is giving you as a huge speed drop. That means there is some issue in that consistency issue, so we should not consider that things. So using this table, we can complement the conventional geometric design guidelines, and we come up with the design parameters which is more aligned towards the driver speed drop behavior. Again, I am saying here this study is about the driver's speed drop behavior along the highway tangent to curve transition, and there are several other parameters also possible. Okay, now my final study I'll be discussing about study number 3. So here I am going to talk about something comfort threshold, but till now I have discussed about speed. If anybody has any kind of question here, can you can ask me along the regarding the speed studies. Let me clarify those, and then I come to the final stage of the study number 3. Anybody has any concern or any understanding issue?
Yes, sir. Thank you so much for providing opportunity. Actually, I wanted to ask about the frictional characteristics, the role of frictional characteristics or parameters when we consider for speed studies. In Indian condition, we generally use a fixed coefficient for friction. Whether it is again sensitive here or without that consideration, we can go forward for the speed studies, sir.
Yes, that is what I will speak in the study 3. Okay.
Okay.
The study 3 about friction values only.
Okay, sir. Okay. No
So
worries, sir.
I am why I asked this. The study 3 I'll be talking about friction, which is actually lateral acceleration,
Yes.
similar kind of thing. So I'll be talking about the friction and very interesting findings we have. I have only
Okay.
another 3-4 slides to discuss. So before I
Okay,
proceed
sir.
with friction value, I wanted to know anybody has any question on the speed studies or the data collection setup. Anyone from the participants? So we can make it's more interactive. So if not, so I can proceed with the my final lap of the discussion. Okay. Okay, fine. It seems that nothing is there, so let me complete the final lap of the presentation, and then I will again come back to take some questions and more interaction on that. So, as Mr. Yogesh mentioned, so it's rightly mentioned. Just let me go back to the what he wanted to ask. Just a minute. These values. Okay. So here I talk everything about the speed in these slides, right? This is actually design speed, and we try to compare these two studies, research studies I discussed. Those are on the operating speed, and we try to compare the operating speed with the design speed or expected speed, and super elevation also there. Now what Yogesh sir is asking that how friction plays a role. This friction, that's why I mentioned here, this friction is actually a comfort threshold. Okay, the moment a driver feel uncomfort, when a driver feel uncomfort, when the friction value is less, that means he or she will be giving like centrifugal force is pushing that vehicle outside the carriageway. So that means the friction is not able to balance the comfort, and we are going out of the carriageway. So this is a dummy, or this is another comfort threshold is a representation of this friction value. Okay. So if we come to the last lap of my discussion is after the application. So this is the study. Here we are talking about, we have done our study using those frictional value. This is comfort threshold modeling at curves, the vehicle stability and friction demand. This comfort threshold is related to vehicle stability and friction demand. When the friction demand is high, the moment the friction demand is high, at that time drivers start to feel the discomfort. That's what I discussed in just last slide. When I go back, I discussed on that. So the similarly, we have in this study, we have taken total 58 curves. Similar data point we have discussed on the first study. 85th percentile of comfort threshold, that is acceleration, 85th percentile of acceleration value, that is lateral acceleration, and no significant difference. What we find, we have selected right turning and left turning curve. We have compared it using t-test, and we find whether a driver taking a right turning curve or it is taking a left turning curve. There is no significant difference between their comfort threshold or 85th percentile of the acceleration values. So this is the plot how it is looks like. The red color represents the left turning curve acceleration profile, and the blue indicates the right turning curve acceleration profile. And there are three zones. First is acceleration is increasing, zone 1. There is a zone 2 is the static or stable acceleration, this is constant value, and again acceleration is reducing. Okay, so this is something kind of deceleration value. So this zone 2 has been considered as fixed value, and we try to understand fix this value as a expected or their threshold, their demand of the lateral acceleration. So based on that, this AC55, this again 85th percentile of comfort threshold. Comfort threshold is nothing but 85th percentile of lateral acceleration value, which is actually F value. Okay, so F value as 0.15 we consider as per the IRC guideline, 0.15. This F value and lateral acceleration is same. So what we are, this is the standard value, this is the line if you say as per the conventional guideline. So anything coming bottom of this line, it's safe, but anything going on the top or above of this line is unsafe. So we see that when the radius is somewhat this beyond this value, under this value, there are friction value or their lateral acceleration value is increasing. These are some values which has to be, these are some geometries which need to be taken care. Okay, so that we try to understand from the field data. So coming to this, again we developed model. Why we always try to develop a simple linear model? Because many people asked, and we have done a lot of research on that. So why it not can be a AML model? It cannot be a your non-linear model. That model may, we from our study, when we compare both the model, whether it is a linear regression or any other kind of technique, there is no significant difference. And why we prefer to use linear regression? Because it is easy to interpret and easy to use by the practitioners or to develop such kind of curves. I mean, it is handy to use when we develop that. And as this is not getting a significant different result from the other modeling techniques, so why not to use this one simple technique and give it more usable or application oriented to the civil engineering domain. So we have finally get using this multilinear regression model, 95% confidence interval. This model we selected, and this is find as the best. Some if you put more data, there may be little bit change, but eventually these parameters are not going to change so much. So these are the model developed. How we can do that? The applications of these models are the margin of safety that can be assessed during the design phase and the new highway corridor design and rehabilitation also. What is this greenfield highway corridor design? Also we can use this, and already existing, if there is a highways is there, we can use this study and identify what are the critical location, and we can put some road safety measures, and also to identify the maximum curve radius corresponding to the unit value of this one. So this is the interesting outcome I wanted to show you, the most interesting part of this lecture. This blue line is indicate the AC85, that is acceleration or side friction values, which is reducing with the, these values are reducing with the various values of when the radius is increasing. The red line is for 4-lane road highways, and the blue line is for two-lane highways. And this formula, these studies, they're taken care by some other study. It is published in ASC Part A, and they developed this equation, this model at their studies, and they find it. They developed it for two-lane highways, and we tried to develop it four-lane highways. What we find here, you see, interestingly, for 0.15 value, which our guideline says, if we go with the 0.15 value, so we see that minimum radius requirement is 380. Okay, and for four lane, the minimum radius requirement is 360 for make it safe. Okay, again, point to be noted again here, this R is 380. It's based on this study, 380 we are getting corresponding to the comfort threshold or side friction value of 0.15, and this 0.15 is suggested by the guideline. So now we try to understand what is the minimum radius required. So minimum radius, desirable radius is a minimum, not absolute minimum, is 380 for two lane, and in our study we find it 360. Now go back to somewhere, just remember this value. Now go back to somewhere here, just a minute. So what does it say, our guideline? This guideline says, this is for both currently in revised guidelines, says that minimum desirable is something about 400, right? And this, and they are proposing it for plain and rolling that 400 is for both the highway type, like two lane as well as four lane. We should go desirable minimum of 400 meter of horizontal curve radius. Again, I am telling this 400 minimum desirable radius is applicable for two lane as well as four lane. But what we find from our study, as I mentioned, if you see again, go back to that slide. What I find, we find it is 400 is almost matching with the guideline, but for four lane it is not matching. Four lane, our demand is it should be minimum 630. Okay. So this is the research outcome we find, and we will try to deliberate on that. This is a very preliminary result, and this result may further change also with more data. But some interesting trend we identified from this study, that the value we are suggesting in the guidelines that may need some interventions. Okay, so like this way the findings we have find. Now whatever all the studies I have discussed, these three studies, and I mentioned this black part, select initial design speed, that we did. It is as per the conventional geometric guideline. Similarly, select the design values of super elevation, that is E, friction value or R minimum. This is all as per the conventional design. Now, where I start my research discussion, I mentioned that performance matrix based geometric design. So what we are doing, these things we are evaluating using performance matrices like this operating speed drop and the coefficient of friction or this comfort threshold we discussed. Based on that, we are evaluating. When we find these performance matrices are consistent with the conventional design, then in that case, if it is consistent, if yes, our conventional design is good, we can go for that. But here from our research, we are adding one more loop into that. If it is not consistent with the conventional design, if there is some consistency issue, then again go back and refit your E, F and all the design values until this become consistent and final design is executed. The overall, like the topic of today's lecture or this workshop is sustainable design or safe design. So this discussion is about that, the how we can make the existing design more sustainable and more human centric. Obviously physical sciences will be there, the Newtonian mechanics will be there. Apart from that, we need to also include the driver behavior and check whether the conventional design is giving us safe facility with respect to the driver behavior. So this is the red part what we have done in our discussion. So this slides is showing similar kind of thing. This is some kind of a dashboard. It is developed. This is IHSDM, Interactive Highway Safety Design Modules. Okay, it is developed in United States of America, and they have developed this, and they put all these input values. And if you see here, this is the before implementing these values. It is the red alignment. Sorry, white alignment. It is before implementing, putting it into the software. When you put into the software, you can see that red part and yellow part. Red part is saying that it is an inconsistent design, and yellow part is teasing, I mean, it is poorly inconsistent and it is fairly inconsistent, something like that. And based on that, they developed this kind of software, which is the basis of this software development. Whatever the discussion I discussed over the 3 studies, similar type of model we are trying to develop, and we can help our conventional guideline in India with this kind of thing. So this is IHSDM is actually a commercial CAT package where driver vehicle module is there, traffic analysis module is there, and consistency module is there, accident analysis module is there, and policy review module is there. Out of that, I discussed only about consistency module in this study, and this is the some few snapshot from the consistency module. What is happening here? Design alternatives. These design alternatives coming from the conventional design. Now this conventional design, here we are putting the conventional design value in this window. This is commercial CAT package. And again, we go to the consistency module. We run this design alternative through the consistency module, and we'll revise the alternative. It is not consistent. Okay. So like that, this field actually emerging in India. So we are developing, we are trying to develop this kind of thing for our country. And thank you. That is the, I tried to tell you, give you some understanding on that. And all the content I discussed here is from my research group, Mr. Mohammed Atif and Vinay Kumar Sharma. Both of them have worked on this, and I co-supervised him. So any question now, if you have, we can take it up.
Inge sir?
Yeah, I'm done. Okay.
Yes,
Hi, sir.
participants.
Thank you.
Yes, participants. If you have any questions or query, you may ask now.
Sir,
Yes,
sir,
please.
I have a question. Which tools or technology are most accurate to collect the speed data?
Which
Technologies or tools?
for
Uh,
collecting speed data?
yes.
Yeah. See, there is, you cannot say which is more accurate. Currently, I mean, if we are using GPS based devices, the ability of the GPS is when it is a more accurate GPS we used, we can say that is compared to more accurate compared to the radar guns or speed guns.
Okay.
Okay, so that is what in some of our study we have compared that, and with the radar gun data or trap length data and the GPS data, the more accurate the GPS capability is, accuracy, so that is going to give you the more data. And if you say that GPS and LiDAR data, that is nowadays is giving the more accurate values compared to other.
Okay, sir.
Okay.
Thank
Gaurav Sil sir?
Ha.
We have conducted one study on national highway nearby Nagpur
Hmm.
before a year approximately,
Hmm.
and we used a Viacom friction apparatus which has been imported from Netherlands,
Okay.
and actually they were you can say promoting their equipments in India, and somehow we got that particular equipment, and we
Hmm.
have conducted that study for identifying the actual friction on the road, and it was about 20 kilometers stretch of that national highway we have tested, and around in 70% of that road area we have identified that the friction required, the value of which we identify, it is less than the friction required as per the guidelines of IRC, which is 0.35 to 0.4 we consider.
Yeah,
So
that's about the longitudinal direction,
yeah,
right?
longitudinal direction, and many times it becomes difficult to maintain that friction in longer run as well. So
Correct.
do you have any, your insight on this particular discussion, sir?
No,
So how we can improve this kind of friction, how we can periodically maintain this, evaluate the friction as well as maintain this friction for the entire road safety?
so that is a part of your pavement design when it is coming to the pavement design. So yeah, obviously, what kind of characteristic road surface we are going to prepare, we can do such kind of material design or mixed design, and we can understand, we can simulate that also, what is the friction value we are getting, and based on that we can do some empirical study or simulation, we can come up with those values. But it is not directly related to traffic. Basically it is a material property or friction values.
Yes, sir. And also with the increasing number of rigid pavement in India,
Yes.
in urban as well as in highway conditions,
Hmm.
this frictional value becomes, very much point of attraction, as you know that the accidents are the prime, the frictions is the prime reason of
Yes.
behind the accidents. Or you
Yes.
can also consider that it is a savior in case of accidents. If you
Hmm.
have the proper friction on the road, we can save a lot of lives in those conditions. So, according to your research, we should also give a lot of importance to the frictional values while designing the road.
Yes, yes, very true. So, what is the value you got in your this study? Maximum value of the side friction. I mean, this
Uh,
F value you
w- w-
got.
we kept the threshold of 0.35 to 4, but around 0.2 to 25 maximum in road stretches we have observed that 0.22, between 0.2 to 0.25.
Yeah, that is actually we
Yeah.
maintain that value. See,
And this
whatever
is
I
again a
discussed here.
concern point for rigid pavement, I'm saying, sir.
Yes, yes, yes. You are very true. The frictional value on the rigid pavement is much less compared to the flexible pavement. In
Yes,
my
sir.
today's discussion, I didn't measure the friction value. I measured
Mm.
a derivative or a representation of the friction value. Why do we
Yes,
use the friction? Friction is nothing but about our comfort. And
yes,
when it
sir.
is going beyond the, when you are on a horizontal curve, when the friction value is not able to resist or counteract the centrifugal force. So it is that a dummy of comfort threshold, this lateral acceleration we are doing. By using the
Yes, sir.
side friction value or friction value, we are only counteracting our centrifugal force or your lateral acceleration. So this is the
Yes,
dummy.
yes. Yeah.
So as you were mentioning, so we can use there are now this is a matter of maintenance. You are true. I mean, a periodical
Yes,
maintenance. So we can
yes.
do something some research you can do like using some drone based survey or something survey, regular
Mhm.
maintenance, image processing, something like
Yeah.
that. We can come up with some development which can give you the
Yeah.
highways maintenance authorities, concessionaires are there.
Mm-hmm.
They can periodically with every month or bi-weekly something they can run through
Yeah.
roads and try to predict what is the status of surface, and then they can improve. And the value you were saying, I think it is on sunny condition, sunny day condition. Further, if it is
Yeah, yeah.
windy
It is
condition,
in
it won't be correct.
day condition. Yeah. Around summer season, we have conducted that survey.
Yes, yes,
One
yes.
more thing, sir, I'm finding a research gap here that in our Indian condition, we do not have that particular handy equipment to identify friction characteristics of the road pavement.
Hmm, true.
Either we have to go for extensive, you can say, test, but there are no such quick test for identifying the road friction. As per my knowledge, I may not know that you must be having some idea about it.
Something
But
called British pendulum test you can that people use to estimate the friction value. British pendulum, the very conventional test, and if
which test did you say, sir?
British pendulum test,
British
British
pendulum. Oh, yeah,
uh,
yeah, yeah. That is an equipment. Yeah, but
apart
it is
from
very old equipment actually.
yes, yes, yes.
Yeah,
So I am also not aware if other than
yeah.
that latest state of the art equipment is there or not.
No worries,
I'm
sir.
not aware of that, but I know that very conventional equipment is British pendulum test. I think nowadays also
Yeah.
people use that only, but I'm not sure.
Yes. Sir, your presentation was very nice, sir. As I have seen you like going into the depth of research in IIT Bombay, your presentation is also that detailed and very well organized, sir.
Thank you so much. I have one question from Mr. Siddhar MK. Okay,
Okay.
I
Yeah, you
think he
can.
asked 833 that is this model useful for expressway speeds? No, sir, it's not acceptable. This is the study, empirical study has been done on 4-lane divided and 2-lane highways. So as I mentioned, there are different kind of roadway characteristics, roadway type or classification are there. Here, this study only talked about 4-lane divided and some of this part 2-lane divided. But these results are not applicable for the expressway. There maybe the values will be different because that is more access control. Their speed will be more, like you have rightly mentioned, the design speed is more than 100 kmph. So you need to further go, do empirical study, collect data, and come up with the model of the expressway. as far as my understanding in this field last 8-9 years, so currently there are very limited study in that area which has been done in expressway. Yeah, there is a huge gap to do to understand similar thing on for expressways also. Thank you, Mr. Amish Sheikh, for your compliment. Thank you so much. So, any other questions, clarifications, and to get more understanding or information from my research, you can visit my website. There are a lot of papers are there in that area. So, yeah. Anything else? I'm just stop sharing my this.
Any questions from participant? Okay. So on the behalf of organizing team, I extend a heartfelt thanks to Dr. Gaurav Sil sir, Assistant Professor IIT Indore, for delivering the highly informative session on the safe and sustainable approach in the road geometrical design. Your insight on design standards, safety, and sustainability were truly valuable. Also, thanks to all the participants for their active engagement and the organizer for ensuring the smooth session. Thank you once again, and we look forward to more such an enriching session. Thank you so much, sir.
Yeah, thank you everyone for your attention. I am happy to see that more than 80 people are attending in late evening also. Thank you. Thank you so much. Thank you all.
Thank you very much, sir. Good night, sir.
Good night.
Right.